Okay, so for those of you watching this at a later date, a few of us from class are here. We're going to take a look at the notes from section 5.3. And we're going to start with page 6. Well, it's not working quite yet. I don't know what's wrong with it. Okay, here we go. I'm looking for page number 6. Can everybody see that?
Yep.
All right, awesome. I'm going to make it a little bit bigger. That'll probably help. And so first of all, I want to point out that there is a slight typo. There is a negative sign in front. It says to graph f of x is equal to negative. I don't want it to be negative. So we're going to change that to positive. And we're going to graph f of x is equal to 0.3 cotangent 2x plus pi over 2. And we're going to do that the same as we did in class. So we're going to have the general strategy over on the right, and this is going to be for y equals a times the tangent of bx plus c plus d. And, oh, there's a slight typo here. One of these should really say cotangent. Okay. So our first step in general is going to be to graph y equals the tangent of x, or y is equal to cotangent x. And so because our particular function involves cotangent, we're going to start with graphing y equals cotangent x. I'm going to kind of just do that off to the side here, and I'll do the best I can. It's a little bit hard to graph with using the computer, but it kind of looks something like this, and it's got an asymptote at 0 and an asymptote at pi. So here's our graph of y equals cotangent of x. I'm going to move the cat out of my way. And then our next step is to just change it with b. So we're going to graph y equals the tangent of b times x, or y equals cotangent of b times x. And so what that means for this example is we're going to graph y equals the cotangent of 2x. Does anybody want to tell me, do you remember what that's going to do to the graph, putting that 2 in there? No? Okay. Well, that's going to change the period. And so in general, for either tangent or cotangent, the period is equal to pi. And so when we put in the b, that changes the period, and the period becomes pi divided by b. And so for this function, the period is going to be pi divided by 2. So what that's going to do, that's going to change our graph. It's still going to look roughly the same, but now we're going to have an asymptote at pi over 2.
I have a question.
Sure, go right
I
ahead.
don't know if I missed something, but wasn't the period 2 pi over b last time, or?
Okay, so when you are graphing sine or cosine or secant or tangent, the period is 2 pi over b. Or excuse me. So when you're graphing sine, cosine, secant, or cosecant, the period's 2 pi over b. For tangent and cotangent, it's going to be pi over b.
Oh, cool.
Good question. So we've got now a rough graph for y equals the cotangent of 2x. Were there any other questions? Okay, next we're going to throw in the C part. So we're going to graph y equals the tangent in general of bx plus c, or y equals the cotangent of bx plus c. What do you think C is going to do? Any ideas? We're going to graph y equals the cotangent of 2x plus pi over 2. What that's going to do is it's going to shift it. It's going to shift it left. In general, it's going to shift negative C over B. So for this one, we're going to shift negative pi over 2 divided by 2, and that's going to be shifting left because of the negative sign, pi over 4. Is that okay with everybody? Okay. All right. And so I'm going to just adjust this graph that I've been working on down here. And this point right here, can you guys see that point I just tried to draw? That point is at pi over 4, 0. It's right in the middle between x is 0 and x is pi over 2. And so this is the point pi over 4, 0. And if I shift that point left, pi over 4 units, that becomes the point 0, 0. And so my very, very rough graph looks like this. And my graph right here, my last graph, had asymptotes at x equals 0 and at x equals pi over 2. So now my new asymptotes will be at x equals pi over 4 and x equals negative pi over 4. Is that okay? Any questions? Okay. So next, we're going to see what the A does to things. So we're going to graph y equals A tangent of bx plus c, or y equals A cotangent of bx plus c. And A stretches or shrinks the graph vertically. Does that make sense? Okay, so we're going to graph y equals a 0.3 cotangent of 2x plus pi over 2. And this is going to shrink the graph because A is smaller than 1. It will shrink the graph. Does that make sense? Okay. And so I want to talk a little bit more about some points on the graph. So back in our very original graph, we had a point right here. This was the point pi over 2, 0. And then we had a point right here, which was the point pi over 4, 1. And then we had a point right here, and that was the point 3 pi over 4, negative 1. Does that make sense to everybody? All right, so then next, what happens was we shrunk the graph horizontally, and so we ended up changing the period. And so we had this point right here where y is 1. It used to be pi over 4, 1, but now it's pi over 8, 1. And then we also have the point where y is negative 1 right here. That used to be 3 pi over 4, 1. Now that's going to be 3 pi over 8, 1. And then next, we moved the graph to the left, pi over 4 units. And so we have the point up here where y was equal to 1. And when we move that over to the left, pi over 4 units, that becomes the point negative. X is negative pi over 8 and y is 1. And then we had the point where y was negative 1, and we're going to shift the graph to the left. So that becomes the point pi over 8. Oops. Pi over 8, 1. Okay. And now I'm ready to make my real graph. I'm ready to incorporate the value of 0.3. And so when I do that, actually, I'm going to change the numbering on my x-axis. So I'll do that first. So instead of calling this point pi over 2, I'm going to call that point pi over 4. And instead of calling this point negative pi over 2, I'm going to call that point negative pi over 4. I'm going to change the point pi into the point pi over 2, and the point negative pi into the point negative pi over 2. And then 3 pi over 2, I'm going to change that into 3 pi over 4. And same thing for negative 3 pi over 2. I'm going to change that into negative 3 pi over 4. And then 2 pi, I'm just going to turn into pi. And then negative 2 pi, I'll also turn into pi. Okay, so I've changed the numbering on my x-axis. And remember how in our very last graph, we had an asymptote at pi over 4. So I'm going to go ahead and reproduce that asymptote here at pi over 4. And another asymptote at negative pi over 4. And the distance in between those two asymptotes is pi over 2. So we're going to have asymptotes that are that same distance apart. So I'm going to go ahead and put in another asymptote at 3 pi over 4 and another asymptote at negative 3 pi over 4. Is that okay so far? All right. And we know what our graph is going to look like. The thing is, we have on our last graph, we had a point where x was negative pi over 8 and y is 1. And that's going to change because the y is going to become 0.3. And then we have negative pi over 8. And then the other point where y was negative 1 is going to become negative 0.3. And the x value is going to stay the same at pi over 8. And then we have a point here at 0, 0. And we're going to try our best to connect those with a smooth curve. Doesn't look very good. I'm going to try again. I'm going to use a different color so maybe you can see the corrected version. It should be more like this. And then my other one should look something like that. Does that look okay? Then I'm going to go ahead and just, oops, sorry, that point should be down here at negative 0.3. This should be up at positive 0.3. And we're going to try to connect them with a smooth curve like we had before. And looks something like that. Okay. And now if we had a value for d, which we don't, we would use that to shift up or down. So we shift up if d is positive, and we shift down if d is negative. And that's method number 1. Anybody have any questions on method number 1? Okay, then we're going to take a look at a second method. We're going to use the exact same function, but we're going to look at a different method. So the first thing in this method is to calculate the period. And the period is pi divided by b for tangent and cotangent. And so for this one, the period is pi over b, and so we get pi over 2. And then the next step is to find two neighboring vertical asymptotes. Okay? And for the tangent function, if we're doing the tangent of bx plus c, to find the asymptotes, we would say bx plus c is equal to negative pi over 2, and bx plus c is equal to positive pi over 2. That's how we can find the vertical asymptotes. For cotangent of bx plus c, we would do bx plus c equals 0, and bx plus c equals pi. Okay. So to find the vertical asymptotes for this particular function, my bx plus c is 2x plus pi over 2. And because I'm working with cotangent, I'll set that equal to 0. And that gives me 2x is equal to negative pi over 2. And to solve that for x, I divide both sides by 2, and I get x is equal to negative pi over 4. Is that okay so far? And then for my other asymptote, I will set 2x plus pi over 2 equal to pi. And so I'm going to subtract pi over 2 from both sides, and I get 2x is equal to pi over 2. And then I'll divide both sides by 4, and I get x is equal to pi over 4. So now I know where I have some asymptotes at negative pi over 4 and positive pi over 4. I'm going to go ahead and fill them in the graph. First, I'm going to change the numbering on my x-axis. So I have pi over 4, pi over 2, 3 pi over 4, and pi, just like up above. And then negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. And so then I'll go ahead and fill in my vertical asymptotes at pi over 4 and at negative pi over 4. And so now I know how far apart my asymptotes are going to be. So I'm going to go ahead and fill in my other vertical asymptotes. Okay. And then I'm actually going to note that over here, we're going to find the x-intercept that's between the vertical asymptotes. And so for the x-intercept, for the tangent of bx plus c, the x-intercept is at bx plus c equals 0. cotangent of bx plus c. The x-intercept is at bx plus c equals pi over 2. Okay, so we're going to go back and figure out what our x-intercept is, and we're working with the cotangent function, and so we're going to set bx plus c equal to pi over 2. And so that's 2x plus pi over 2 equals pi over 2. And the first thing we'll do is subtract pi over 2 from both sides. So we get 2x equals 0. And so that tells me x equals 0. So I have an x-intercept at the point x equals 0. I'm going to go ahead and plot that right here. And then the next step, well, first you're going to plot the asymptotes and intercept, x-intercept. And then we're going to make a table of values. And so we'll make the table of values down here towards the bottom. And so we're going to have x, and then we're going to have y, which is 0.3 times the cotangent of 2x plus pi over 2. And my first value that I'll plug in is negative pi over 4. And I know that I have an asymptote there, so that's undefined. The next point I'm going to plug in is negative pi over 8. And if I plug in negative pi over 8, I have 0.3 times the cotangent of 2 times pi over 8 plus pi over 4. And so I get 0.3 times the cotangent of pi over 2 plus pi over 4. And so that's going to be 0.3 times the cotangent of 3 pi over 4. And that's going to be 0.3 times 1, which is just 0.3. That makes sense? The next one I want to plug in is 0. And when I plug in 0, I'll get 0.3 times the cotangent of 2 times 0 plus pi over 4. 2 times 0 is 0. And so we're going to get 0.3 times the cotangent of just pi over 4. And so that gives me 0.3 times 1, and that just makes 0.3. Next, I'm going to plug in pi over 8. And very similar to what happened when I plugged in negative pi over 8, I'm going to end up with 0.3 times the cotangent of, oh, hang on one second. I think back here when I plugged in negative pi over 8, I did something wrong. Okay, so I'm going to have to come back and fix that. I'll keep going with positive pi over 8. We're going to have 2 times pi over 8 plus pi over 4. And that's actually going to give me 0.3 times the cotangent of pi over 4 plus pi over 4. And so that's equal to 0.3 times the cotangent of pi over 2. And that is 0.3 times 1, which is 0.3. Okay, so back over here, this 4 should be an 8. Not quite sure how to erase things. So So right here where this should be an 8. And so this should be a 4. Oops, but this is negative pi over 8. And so this is negative pi over 4. Huh. I'm going to have to see what happened on that one. I'm not quite sure what I did to mess it all up. Does end up being, let me think for just a second. Okay, I'm going to have to come back and fix that one. We're going to end up with a point here and a point here. This will be 0.3, and this will be negative 0.3. And then we end up with our nice smooth curve, like so. And we can go ahead and fill in a few more of these.
I do have a
Yeah, go right ahead.
when we're doing this, why do we go from pi over 2 to pi over 4? For like, because it says y is 0.3 times the cotangent of 2x plus pi over 2.
Yeah.
So
Oh,
why
did
is
I?
it?
Oh, that's what I did wrong. Thank you so much.
Yeah.
Okay. Thank you. All right. So this should be a 2 right here is what you're telling me. And this should be a 2. Thank you. I was trying to figure out what I had messed up here. Okay. So we had, what just happened? Oh, somebody raised their hand. Who raised their hand? Was it Eric?
No, I think it was someone else.
Oh. Oops, I don't need to raise my hand. Okay. All right, is that okay with everybody so far? So I'm going to go back and see if I can fix my mistake. So this was supposed to be a 2, and this was supposed to be a 2. And then this was a negative pi over 8, so that became negative pi over 4. And now we're adding pi over 2 to that. So let's see, we have negative pi over 4 plus pi over 2. That would become pi over 2. And then over on this side, we have 2 times pi over 8 plus pi over 2. And so that would become pi over 4 plus pi over 2. And that would become 3 pi over 8, 3 pi over 4. And so that's going to give me 0.3 times negative 1, which is going to be negative 0.3. Let me try that again. 0.3 times negative 1 is negative 0.3. Okay, so sorry about that. Did anybody have any questions at all on page 6? Okay, I'm going to go ahead and stop the recording now.